Okay, this is going to be our notes on matter, actually describing matter or identifying matter. And I don't have a real good use of a pen here, so you're going to have to bear with me. My writing ability is not very good, so I'm going to have to type some in. I hope that works all right for everybody. But here we have describing matter. We have these physical properties, and when we look down here, we're going to see that we also have something called chemical properties. And both of these properties, whether they're physical properties or chemical properties, both help to define what the substance is that we have. So this definition goes to this, and it goes to this. Okay, and so you might say, well, what do they even matter? Why do we worry about physical and chemical properties? Because sometimes we need them to identify what we have. So if we have table salt, which is sodium chloride, we could write it as NaCl, sodium chloride. And if we knew we had sodium and chlorine in something, and they were both a 1-to-1 ratio, we'll learn more about what all this means in a minute, or actually later in this week or so. But if we have 1 sodium to 1 chlorine, we know we have sodium chloride. But let's say we can't figure out whether we have sodium and chlorine. Then we have to find another way to identify what we have. And we can do that through these kind of properties, either physical properties or chemical properties. Physical properties, what makes them different than chemical properties is this: they can be observed without changing the substance. So examples of these are boiling point, freezing point, density, mass, and volume. But there's a difference in these, and we call these ones intensive boiling point, freezing point, density, and we call these mass and volume extensive properties. Because intensive properties, how they're different, they both can be observed without changing the substance. But some depend on the amount and some do not. Okay? So all these properties, these physical properties, they don't change what it is. So like example, if we have a glass of water, put some water in it, and we then heat it up. So we put some fire in there. Okay? We're careful, we want to make sure it's a Pyrex glass and all. But as we do that, it'll start to steam, and the temperature will increase because we're introducing some energy into the water, make the molecules move faster, and they're going to start to change state. They're going to start to warm up, and they're going to change from a liquid to a gas, G. And there's a point where there's a temperature where things start to change from a liquid to a gas, and we call that the boiling point. There's also, we can go back, so we can go the other way. So let's say we didn't have fire, and instead we put ice on it. So if we put some, we'll do blue for this. So if we put ice cubes around this, these ice cubes aren't perfect. My pen abilities aren't the greatest without my board, but I'm doing my best. And we do that, and we would freeze this, and this liquid that would then change into ice. The water inside here eventually would change into a big block of ice. ICE. Okay? And it wouldn't change it being water. It would still be water, but now it would be in its solid form, ice. And if we then applied heat again, we went to red, we then applied heat again, we could then change this ice back into water in a liquid, and then if we kept producing heat, we could change it into a gas. And those are all changes of state. But the points where they change from one thing to the other, liquid to a gas, or a solid to a liquid, or liquid back to a solid, those are points, specific points for specific things. So water, H2O, it freezes at 32 degrees Fahrenheit or 0 degrees Celsius, and it also melts at the same temperature, and then depending on what happens, it'll either become a liquid, or if you're making it cooler, it'll become ice. But it also has a boiling point, water does. And so if we heat it and heat it and heat it at 100 degrees Celsius, it's going to boil once all the water has reached that temperature, 100 degrees Celsius. So, but these are intensive properties. So if we had a truckload of water, if we bought in a big, I'm trying to make a truck here. Excuse my drawings. They're really bad. I can't control my pen very well. Oh, very bad. Put the wheel down here, bigger wheel here. So if we had this was nothing but H2O, and we boiled it, it would boil at 100 degrees Celsius. If we then took a little cup of water, very small, and we boiled that water, it would boil in a small cup. We then boiled that, it would also boil at 100 degrees Celsius because it's an intensive property. The amount you have does not matter. And if we froze this water, if we drove it to Antarctica and we parked the truck and the water froze, it would freeze at 0 degrees Celsius. And if we took a cup of water and we took it to Antarctica, it would freeze at 0 degrees Celsius. That's an intensive property. Another example of that is density. You can kind of look that one up. Extensive properties are properties that depend on how much you have and whatever that measurement is going to be. Because these really are just measurements. What is the temperature of it when it changes from a liquid to a gas? And what is the temperature when it changes from a liquid back into a solid? And so on. Density. How much mass per unit volume do we have? They're all just measurements. We can measure mass by, how many kilograms is it? And volume, by how many liters. These ones, it doesn't matter how much you have. They're always going to be the same number for the substance. These are different. So if we have a bucket of water, we might have 1 liter. If we have a truckload of water, we might have 1,000 liters. It's still water, and this is a property that it changes. It's an extensive property. It still doesn't change what it is. You have a truckload of water, you have water. If you have a bucket of water, you have water. If you have a thimble full of water, you still have water. Mass and volume are extensive properties. It depends on how much you have of the substance. Okay? And those are physical properties. If we then look at the next one, I'm going to erase this. If we then look at the next property, it's a chemical property. Chemical properties are properties that observe when matter changes. Okay, so a good example that we usually understand is in middle school we always do the experiment, baking soda and vinegar, no water. So baking soda, put a V on this for vinegar, we'll put bake, see how good I can spell it, I'm not doing too good with this. Baking S. So baking soda. So say we have some white powder. We don't know what it is. Maybe it's salt. Maybe it's baking soda. Maybe it's, something else we don't know what it is. And we wanted to observe a property of baking soda. We could say, well, when we mix vinegar with it, if we were to shake this and all the vinegar was to come out, then if it bubbled, we could say maybe it is baking soda, and then we could do some other tests on it. And we look at these ones here, flammability. This is the ability to catch fire or combustible, start to burn. And heat of combustion is how much heat we produce when we burn something. And we kind of know this from birch. I'm just going to do a B, or spruce. Everybody wants birch because it burns, produces more heat when it burns for its size. So if you take a birch log and put it in a wood burner, it will produce a certain amount of heat when it burns. And if you put the same amount of spruce in there, it'll produce a certain amount, but it produces less because birch has a higher heat of combustion. And it's a chemical property. And if you take that birch and you put it in your wood burner and you burn it, when you're done, it's not birch anymore. It's ash, and some of the birch has come out, the water's come out of it and gone up your stack, and so on. Some of the carbon has come out and formed carbon dioxide. So the birch wood we had has become H2O. It's become CO2, a greenhouse gas. And then it's also become ash. And that's a chemical change, but if we wanted to observe birch, its chemical properties is it will produce these things when we burn it, okay, and produce a certain amount of heat. So we could say, what kind of wood do we have? Do we have birch or do we have spruce? And we didn't know. We could burn it and see how much heat it produced for its unit size. And if it produces a certain amount, we know it's birch. And that's a chemical property. The thing is, it changes. It's not birch anymore once we burn it. Or you can think of like gasoline, same thing. You put gasoline in your car uses it, burns it. When you're done, you still don't have gasoline anymore. You have something, you have CO2, sometimes you produce carbon monoxide, different chemicals. It produces energy at the same time, but you don't have gasoline after you burn it. It's changed into something else. That's a chemical property that you can observe. And it can help you identify what you have. Flammability, heat of combustion, and there's other ones. But when you observe these chemical properties, it's always important to remember that a chemical change is occurring as well. So you're producing something new. And if you want to know whether that's occurring, you can look for these signs. Okay? And if we go back to the idea of baking soda, we have our baggie. So it'll be purple or gray, whatever color that is. So we have our little Ziploc bag. We have our baking soda in here. Oh, and we have a cup of vinegar. There's our baking soda. I'll just call it BS. Be careful though of that. Okay, and so I mix the vinegar in. It comes pouring out of here, and then what happens? It foams, and what it's doing is producing a gas. So we know the chemical property of baking soda is it foams when mixed with vinegar, but really what's happening, not foaming, it's producing a gas. Okay, that's its property when it's mixed with vinegar. Okay, but we know it's a chemical change because it's producing that gas. Also, what can happen is a temperature change. So if you've ever noticed when you mix vinegar and baking soda, the temperature goes down. It gets cooler. Okay, and that's because it's absorbing energy from the environment, from this baking soda and this vinegar, and it's making it colder. For this reaction to occur, it needs energy. So it takes energy from these bonds in these substances, and as a result, they become colder. But sometimes it actually releases energy, and when it does that, it gets hotter. The temperature of the substance goes up. Like the salt you put on your sidewalk, it melts water because whenever that salt mixes with water, it has a chemical reaction and produces energy. So, and there's some other ones as well, if I erase this here. Color change is one. Sometimes you mix two substances together and you see a really drastic color change. I can't think of one off the top of my head, but so you have this clear substance in here, you mix another substance in with it, and sometimes they produce really vivid colors, blue, yellow, whatever, depending on the substance. And they use these color change ideas for indicators, pH indicators. So you can put something in, let's put IND, so pH. So sometimes you mix chemicals in your pool and it changes a certain color and you know that it's a certain pH. They can use this chemical change to as an indicator of something going on as well. But also you can have something called you can have precipitation occur, and when precipitation occurs, it forms a precipitate. I'm going to type this one because I know I can't. Precipitate. Okay, and that's a solid. Oh, that's not good. Put it over here. So that's a solid. Maybe I gotta go like this. Doesn't want to work. So, okay, get rid of this one over here. Okay. So you take two liquids, put them together, so you could possibly have two liquids here.